Assalamualaikum. My name is Amir Fahim bin Azam and we are from Group 10. Our topic for today is sampling distribution. For introduction, when working with statistics, we often can study an entire population, so we rely on sample instead. But how do we know if what we need in a sample really reflects the whole population? That's where the idea of sampling distribution comes in. A sampling distribution is the spread or pattern we get when we take lots of sample results, like sample means, and see how they behave. It helps us how close our samples is likely to be to the actual population. To really get this, we need to look at a few key ideas. Sampling error, the natural difference between a sample and the population, the sample mean, and standard deviation, also called standard error when dealing with samples. This concept help researchers make better decisions using limited data.
Assalamualaikum everyone. My name is Rafi. Number metric S23B0252. Here we got in screen is impact on statistical conclusions. Let's start with definition. What is sampling error? Sampling error is the difference between a sample statistic and the true population parameter. It's caused by studying only a part of the population. Okay, that's for definition. Why sampling error happens? Sampling error happens because it's random variation between different samples. Number two, small sample size over higher variability. And number three, non-representative samples. Okay, next is impact of sampling error. Why it matters? Because it misestimation of population parameter. Number two, incorrect hypothesis test result. And number three, unreliable confidence intervals. The solution is use larger, well-designed samples. And number two, measure error using standard error of the means. Here we got with illustration of sampling error. This bell-shaped curves represents the population distribution, the true range of values in the entire population. The dashed line in the center is the population mean, mu, which we would know only if we measure everyone. On the left side, you see example of sample means like 68, 70, and 72. These are average values calculated from different samples taken from the same population. Notice how the sample means do not exactly match the population mean. This difference is what we call sampling error. The error label sampling error shows the gap between one of the sample means and the actual population mean. Even with random sampling, variation naturally occurs. Okay, thank you.
Hello everyone, my name is Aqif bin Malik. So I'm gonna talk about the mean and standard deviation of the sample mean. So the sample mean is the average value of a sample, the standard deviation of the sample mean. It measures how much the sample mean is expected to vary from sample to sample. The sample mean calculated is used to find the variance of the thereby and the standard deviation. So as you can see at the right side, we have the formula of the sample mean. So sum of terms divided by number of terms. So we have an example of the finding mean of the means. So we have four terms. So number one is 4.35, 4.62, 4.29, 4.39, and 4.55. So we add all up, divided by number of terms, which is 5. So we got 22.20 divided by 5, and then we got 4.44. This is the example in the chart of the visualization. So we have the number of terms: 4.35, 4.62, 4.29, 4.39, 4.55. So the sample mean after we calculate it is 4.44. So the red line is the presented value of the mean of the means. About standard deviation of the sample mean. So we have the formula is standard deviation. The formula is standard deviation divided by the number of samples. So we have an example of a factory produced metal rods with a population standard deviation of 12 millimeter, and then an engineer takes a random sample of 36 rods to estimate the average length. So we can gather that the standard deviation is 12 millimeter and the sample size is 36. So we have the formula here: standard deviation 12 divided by factor 36. So we got 12 divided by 6, and we got 2 millimeter. This is another example of the standard deviation. We got 12 millimeter of standard deviation, and the sample size is 36. So as you can see in the line chart, we have the relationship between sample size and the standard error. The line, or the blue line, presenting the standard deviation, and then the red line presenting the sample size, which is 36. So this is the line chart visualization for the example.
So, hi everyone. So, what is the definition and the concept of a sampling distribution? So, today we are talking about a key idea in statistics: the sampling distribution of the sample means. So, you can think of it this way. Imagine you want to find average height of everyone in UMK, right? So, you can measure everyone. So, you take a smaller group, let's say 30 people at a time. Of each group, you find the average height, right? So if you do many times, you will get a lot of different average height. The sampling distribution is simply what happened when you plot all of those average on the graph. So here a cool part: as you take a bigger sample, more people each a group, those average height tend to climb more closely around the real average height of everyone in UMK, so they become a less spread out. Okay, why is a matter? Why is a matter? Central limit theorem. So we call it CLT. This accompanying behavior is explained by a super important rule called a central limit theorem, or CLT. So normally people height might be spread out in all sort of way. So but a CLT tells us something amazing. If your sample group are big enough, usually 30 or something more people, then the average you get a more those a group with almost always from a bell-shaped curve like this. So a normal distribution. This is powerful because it let us predict how often we will see a certain sample average, even if we don't know everything about the whole population, right? So it's like a turning random average into a prediction pattern. Like it's a more interesting, like, so you can predict a random average based on the graph, based on the bell shape. So how is it look? A shape, a middle, and the spread. What of that? So what does a bell shape a curve look like, especially for the our sample average? So for the shape, as we just say, is a typically normal, a nice symmetrical bell curve. So this is a thanks to CLT as long as our sample size n is a 30 or more. So it's like 30 people or more people, right? So for the middle is a mean average. The center of the bell curve, or the average of our sample average, will be exactly same as the true average of the world population. We write this as a means. So you know, right? So this means if you take enough a sample, your sample average will on average hit a bullseye. So for the spread, standard error, how wide or narrow is a bell curve. That's measured by something called a standard error of the mean. So it tells us how much our sample average typically jump around from a true population average. So here how we calculate it. So it's a population spread. So divide by a square root of your sample size. And remember how we say a bigger sample mean less spread. So this formula show it. If n your sample size get a bigger, so the bottom part of the fraction get bigger. So making the whole standard error smaller. Smaller means your sample average are squeezed closer together and giving a more accurate guess of bulk population. Thank you. For the real example, why is a matter inferential statistic? Why do a statistician care so much about it? So because it's a core inferential statistics using information from the small group to understand a big group. So it helps us to make a smart decision without having a measure everything. It's a great real world example is Netflix. You watch every day, right? So Netflix recommendation. Why Netflix recommendation? So I want to explain it. Netflix look like ad as some people watch, rate, and like, right? So they use this amount of a sample data for their user, for the watcher, to guess what everything might like. They use a statistical idea to figure out which movie and show recommended to you and what you love about the movie genre. So it's so this help them is a two main ways. So for the first one is a personalization. They can suggest a thing you actually enjoy, keeping you happy and watching. So it's your watch Netflix. So and after you watch the movie, the pop-up recommendation movie, uh, the pop-up you can look out. Oh, this movie I like it, so I watch it later because they read your algorithm from your data. So a second, smart business. This is more important because the money you get. So they use a knowledge to decide which a new show to buy and produce. So the more show the produce, the more show that we provide, and then you can get the more money you get. So making sure they invest their money wisely, correctly, in content that people will love. So basically, understanding this concept allow a company like a Netflix or Disney Plus and other platform to turn customer data into the real business, making better choice for everyone. Thank you so much.
For the conclusion, in short, sampling distribution help us make sense of how sample data reflect a bigger picture. By understanding the sample means, standard error, and how the central limit theorem works, we can see why larger, well-chosen sample give us better result. Knowing this makes us more confident in the conclusion we draw from the data. Whether it's for a research project or a company making big decisions, sampling distribution are an important tool. The better we understand them and how to reduce sampling errors, the more accurate and useful our finding will be. That's all from us. Thank you.